Today's lesson is lesson 3 of Unit 12, adding probabilities and two-way frequency tables. We'll be covering the first half of lesson 3, pages 406 to 409. And your homework is pages 414 to 415, numbers 1 through 8. You don't need anything special today. I suppose just a calculator for adding and subtracting. All right, so we have to get into a little bit of notation. So first here, sometimes we want to determine the probability that either event A happened or event B happened. To do this, we need to be able to account for all the outcomes that fall into either one of the two events. Let's see how this looks in an event diagram. So exercise number 1, consider the spinner shown below that has been divided into 8 equally sized sectors of a circle. The spinner is spun once. In this experiment, we will let A be the event of it landing on an even number, and B be the event of it landing on a prime number. Fill in the Venn diagram below with the actual numbers from the spinner. Okay, so A is evens and B is primes. So even. So the first even here is 2. But 2 is also prime, so that is contained in both A and B, so that's here in the intersection. 4 is even, but it's not prime. 6 is even, but it is not prime. And 8 is even, but not prime. And then prime numbers, well, 1 is not prime, so that goes outside. 2 is prime, but we have it there already. 3 is prime, but not even. 4 is not prime. 5 is prime, but not even. 6 is not prime. 7 is prime, but not even. And 8 is not prime. When we have 2 or more sets, we can talk about their union and their intersection. Okay. The symbol for union looks like a U, and this is also for OR. And the symbol for intersection looks like an upside down U. And this is for AND. Or you can think of the intersection symbol as also sort of like a lowercase n for AND. Oh no, better than that. Let's take the capital A without the horizontal bar, and that's better for AND. So for 2 sets, A and B, their union, OR, and their intersection, and you've got to keep these two straight. Union is for OR, the symbol is that, and intersection is for AND, the symbol is this, are given by A or B equals A union B. That is a set of all x such that x is in A or x is in B. So that's that's the OR that we've been seeing in our Venn diagram. Remember, we always draw up to the side here. Okay, well the 2 circles combined is our OR. Well, now we have a symbol for it. And we also have another name for it, and that is union. These are both sets combined. A and B, which equals in symbols A intersection B, is equal to the set of all x such that x is in A and is in B. Again, when we're looking back at our Venn diagrams, that was the overlapping region. And this would always be our AND region. And this is what is shared between both sets, or contained in both sets. From exercise number 1, write out the following two sets. A or B, which is A union B. So A union B would be the set containing our, you have to, looking back up here, would be 2, 3, 4, 5, 6, 7, 8. A and B, the intersection, A intersect B, would equal the set containing 2. That's it. From exercise number 2, why is the equation the number of elements in A or B? Well, what is the number of elements in A or B? That's 7, right? Equal the number of elements in A. Number of elements in A, I'd have to go, I'm looking back up, right, back up here, the number of elements in A is 4, and then the number of elements in B is these 4, so 7 equals 4 plus 4. Why is this generally not true? Because of the overlap. The overlap was counted twice. Let's say because overlap is counted twice. So a formula. What do we do? How do we get it to equal? Well, I think I mentioned this, I'm not sure what video before, or maybe it was just the last lesson, but maybe not. Since this overlap was counted twice, we can just subtract the overlap one time. So the number of elements in A or B is equal to the number of elements in A plus the number of elements in B minus the number of elements in A and B. And we're going to replace number of elements, the lowercase n, with probability on the next page, and that's going to become the first probability formula you have to memorize. Right? So you already have these two symbols that you need to know. Right? This stands for union, which is or, and this stands for intersection of, which is and. Right, this page I'm going to go quickly through, sort of. Basically, what it's saying here is that you have circle A represents a set of American citizens, circle B represents a set of people who have brothers, and the set of people who are American and have brothers is shown by the shaded region in the Venn diagram. Yep, we know that that's going to be the intersection of the two circles, the overlapping region. So basically, this is our and the symbol for it is, let's look like an A, capital A without the horizontal bar. So this is written as A and B, but read A intersect B. But it stands for and. The set of people who are not, or sorry, the set of people or the set of Americans, okay, rewind. The set of people who are Americans or have brothers is represented by the shaded region in the Venn diagram. Yeah, we know Americans or have brothers. So this is the or. This is our A or B, which we know is the two circles combined. And in symbols, this is A union B, which is for A or B. The set of people who are not Americans is represented by the shaded region in the Venn diagram below. The set is written A with a raise, a superscript of C for the complement, red A complement, or the complement of A. So this is everything outside of A. Sometimes I'll just refer to it as not A, or A complement. Exercise number 5. Think about the cars available at a dealership. Suppose a car is selected at random from the car at the dealership. Let the event that the car has manual transmission be denoted by M, and let the event that the car is a sedan be denoted by S. So manual, sedan. So 0.12 is sedan and manual transmission. The Venn diagram below shows the probabilities associated with 4 of the regions of the diagram. Complete this sentence using and or. Hopefully you can do that on your own. So I'll pause. The probability of M, this symbol, S, is the probability that a randomly selected car has a manual transmission. And is a sedan. Okay. It looks like an A if I put that for and. What is the value of the probability of M and S? Well, the and is the 0.12. Complete this sentence using and or. The probability of M, this symbol S, is the probability that a randomly selected car has a manual transmission. Or is a sedan. Right? This is for union. This is our or. What is the value of the probability of M or S? It's going to be 1 minus 0.19, right? It's going to be 1 minus 0.19, which is equal to 0.81. Or I could have taken all 3 of these and added them. 0.09 plus 0.12 plus 0.6. So this is 0.60 and 0.12 is 0.72 and 0.09 is 0.81. What is the value of the probability of S complement? So that's everything outside of circle S. Well, how much is circle S total. So circle S total, yeah, you can still see that. The lollipop stick here would be 0.6 plus 0.12 is 0.72. So 1 minus 0.72 is one way of answering this question, which is 0.28. I don't think that was the best way. Outside of circle S, I guess the better way would have been to take, well, this is circle S. So what's outside is 0.19 and 0.09. 0.19 plus 0.09 is 0.28. Explain the meaning of the probability of S complement. So that would be the probability that a randomly selected car is not a sedan. Okay, so now we're getting to two-way frequency tables. Which I think you may have seen in grade 7 or 8, I'm not sure. Two-way frequency tables give us a good example of how events or sets can combine their union and overlap their intersection. Let's look at this and develop some ideas about probability. A small high school surveyed 52 of its seniors about their plans after graduation. They found the following data and wanted to analyze it based on gender. In this case, if we pick a student at random, we can place them into one of 4 events. We have M is for male, F for female, C is for going to college, and N is for not going to college. So we have male, so actually let me just take this and put M for male, F for female, this is college, and N is for not going to college. Give the values of each of the following. The number that are male. Okay, the number that are male, make sure you give the total number. There are 16 males are going to college, 14 are not. So the total number of male is 30. The number that are female, total number 22. The number that are going to college, want the total, 29. Number that are not going to college, total is 23. The number of male and going to college, M and C. So M and C would be this intersection right here, 16. The number of female and going to college, so female and college, 13. The number of female or going to college. Whoa. Female or going to college. Well, do we want to use our formula? Or let's see. I like formulas. The number of female or going to college is going to equal the number of female plus the number going to college minus the intersection, minus the number female and going to college. So female's 22. College is 29. Minus the intersection, the and, is 13. Which equals 38. Okay. Or, yes, I understand where you could do female or going to college. Well, there's a total of, if I look at female, there's a total of 22 females or going to college, and then take the 16 additional, in which case 16 males that are going to college. So 22 plus 16 will also get you the 38. What is the probability that a person picked at random would be a female who is going to college? Okay, so we want female and college, right? So this is probability of female and college. Well, I thought we already had that. Oh, but this is probability. Sorry. So that's going to be our number over our total. So that would be 13 out of our total number of students are surveyed is 52. So 13 over 52. Oh, sorry. Of course, I didn't finish reading. Represent this using either a union or an intersection. This is intersection. Probability of F and C is equal to 13 over 52. What is the probability that a person picked at random would be a female or someone going to college? Represent this using either a union or an intersection. Well, this is or, so this is a union. So this is going to be female probability, right? Probability of female or going to college. And that's going to equal, well, the number from above is 38 over the total 52. Explain why the probability of F or C, that's this one, doesn't equal the probability of F plus the probability of C. And the probability of F, female, would be 22 out of 52, plus the probability of going to college is 29 out of 52. That total is 51 out of 52, which is certainly not our 38 out of 52. And why is that? Again, it's because there is the overlap of 13, right? If I'm looking at female and going to college, this 13 has been counted twice. So I'll say explain. So there is the overlap the 13 female going to college, the 13 female going to college would be counted twice. fill in the general probability law in D, or based on D. So the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. That's your first formula that you need to memorize. Sometimes we can avoid the probability law that we encounter in E by simply keeping careful track of what elements of the sample space are in both of our sets and making sure we don't count any element twice. A standard six-sided die is rolled once. Find the probability that the number rolled was either an even or a multiple of 3. Represent this problem and the sets involved using a Venn diagram. Even though you don't need it, verify the probability addition rule from exercise number 6E. Okay, so if I'm using a Venn diagram, first let me write down the probability. We're looking for the probability that the number rolled was, I'm going to say E for even, or a multiple of 3. Or I'm going to say M3 for multiple of 3. Okay. So if we're using a Venn diagram, this is even, multiple of 3. Six-sided die, the outcomes are 1, 2, 3, 4, 5, or 6. So 1 is neither. 2 is even, but not a multiple of 3. 3 is a multiple of 3. 4 is even, but not a multiple of 3. 5 is not even, nor is it a multiple of 3, so that goes outside. And 6 is even and a multiple of 3. And there we have it. There's our Venn diagram. So the probability that a die rolled is even or a multiple of 3 would be 2, 3, 4, and 6. That'd be 4 out of 6. So the probability of even or multiple of 3 is going to equal the probability of even plus the probability multiple of 3 minus the probability of even and multiple of 3. Probability of even, that's 3 out of a total of 6, plus multiple of 3, there's 2 multiples of 3, minus probability of even and multiple of 3, which is the 1. 5 minus 1 is 4/6, or 2/3. There are some situations, though, where the probability addition rule is unavoidable. Insurance companies typically try to sell many different policies to the same customers. At one such company, 56% of all the customers have car insurance policies. So 56% is for car insurance. And 48% have homeowners insurance policies. And 18% have both. Find the probability. A customer is picked at random. Find the probability that she or he has at least one of these policies. So at least, so meaning it's the probability of car insurance, I'm going to use C, or homeowners insurance, I'll use H for homeowners. So we want the probability that they have car or homeowners insurance. In this case, I would use the formula. It's going to be the probability of car insurance plus the probability of homeowners insurance minus the probability of both. .56 plus 0.48 minus 0.18. 30, so 0.86. Find the probability that she or he has neither of the policies. Oh, well, this is the or, so neither would be everything outside of that. So this would be one minus 0.86, which is 0.14. Just want to see, could we have used a Venn diagram for this? We have car, and we have homeowners. And car is 0.56, homeowners is 0.48, and both is 0.18. So yeah, I mean, for the or, yes, we could have. Yeah, we could have definitely done the Venn diagram. 0.56 minus the 0.18. Now I'm going to go this way, it's easier. Take the homeowners H minus 0.18, so that means that this piece is 0.30. And then if all of C is 0.56, and I add that 0.30, I'll get our 0.86, which is the answer for the or, right? Probability that she or he has neither, that's going to be outside. So if this is 0.86, then that's 1 minus it, 0.14. Thank you once again for your attention, and the homework is pages 414 and 415.